When an object is transformed, that is, moved, rotated, or scaled, it needs to be transformed relative to some point of reference, and that is the reference coordinate system for the transform. So when you move something, are you moving it relative to the world grid, or are you moving it relative to the object itself? We can choose our reference coordinate systems from the pull-down list here on the main toolbar. And we have a bunch of options. We're not going to look at all of them, just the most important ones. And the reference coordinate system is sticky for each one of the three transforms of move, rotate, and scale. So if you choose a different reference coordinate system for move, that will not affect the coordinate system for rotate. They're independent of one another. So the default for move is the view coordinate system. And if I select this monitor, I can see that I get a move gizmo if the move tool is active. And in the top view, the move gizmo or manipulator is precisely aligned with this axis tripod in the lower left. That tripod indicates the orientation of the world grid or the world coordinate system. So if I move this monitor in X in the top view, I'm moving it in world X. If I move it in Y in the top view, I'm moving it in world Y. But it's not the same if we go over to, for example, the front view. I'll right-click in that front view so I don't lose my selection. And over here we see that Y is still pointing up to the top of the screen, and X is still pointing to the right, but it doesn't line up with what we see in the world axis tripod. In this front view, the top of the view here is actually up in Z, in world Z or Z. So the manipulator or gizmo always stays the same in an ortho view when you're in view coordinate system. If I switch over to the left view, click there, Y is pointing up and X is pointing to the right. So view coordinate system is the space of the viewport itself. And that's fine for an orthographic view, but in the perspective view, we don't necessarily want to move in screen space. We usually want to move in world space. So if I go over to that perspective view and click there, we can see that the move gizmo is aligned with the world axes, as shown here. So if I move in X, I'm moving in world X. So the view coordinate system operates in screen space, except for in a perspective or camera view, where it operates in world space. Let's look at these other ones here. So if we choose screen, that is in screen space in all views. So if I go over here to the perspective view and move this in X, I'm actually moving it not in world X any longer, as we can see in the top viewport. It's moving in X and Y because I'm moving relative to the view plane of the perspective viewport. All right, well, I don't usually use that. One that you'll use a lot is local, and that's the space of the object. And in this case, it's the space of a group, which is an invisible container for a bunch of objects. We'll look at groups later, but this monitor is an assemblage of objects all put into a group, and the entire group has been rotated so that the local coordinate system will show us the axis tripod or the move gizmo oriented with the objects themselves and not with the world and not with the screen. So local mode is really useful if you want to, for example, push something forward or to the side in its own space. Now that local mode is kind of fake because if you animate this, you will find that you're not just moving in Y. So if I try to animate this, moving in that direction, what I would find is I'm actually animating in world X and Y because the object has no parent. So local mode is useful for modeling operations, but if you're going to be animating, then you'll need to look a little bit deeper. And we'll talk about that more when we get to rigging and hierarchies. Let's move on now to the rotate tool. And it's got view and world coordinates as well. And it's got local coordinates. Local coordinates will be easier to see if we select a single object rather than this group or assembly. So I've got an object over here, this dodecahedron. It's a single object. And I can use my newly minted keyboard shortcut that I created in the previous movie to zoom in on that object in all views. And it's Shift-Control-Z for zoom extents all selected down here. If we look at this in the perspective view, we'll see that the rotate gizmo is not oriented with the world. And we might need to dolly back a little bit farther to see that more clearly. Let's do that in all the views so we can actually see the rotate gizmo very clearly. And we see that it's not oriented with the world. It's arbitrarily rotated. And if we go over here to world, we'll see the actual rotation values. So it's been rotated 31.674 degrees in world X. When we switch to local, it reads as 0. So that's kind of disconcerting. If you're in local mode, it'll always read as 0. And you can still rotate in whatever direction you want, but just like with the move tool, local reference coordinate system is kind of fake, and the fact that it always returns back to 0 should be a dead giveaway that something strange is going on here. So I'm going to undo that with Control-Z. I don't recommend using local mode if you can help it. It's got a lot of problems, not the least of which is something called gimbal lock, when the axes actually overlap and you can't rotate something. What I recommend for rotations in most cases is the gimbal coordinate system. And what that does is it allows us to visualize how the three axes interact. So I'll go over here to the perspective view, and if I rotate around the Z-axis, everything looks normal. Nothing strange there, so I'll undo that. If I rotate around the X-axis, again, it looks fine. Nothing strange. I'll undo that. But if I rotate around the Y-axis, notice what's happening here. The red axis is actually rotating. So what's happening here is I'm seeing the effect of gimbal lock if I bring this red axis down until it meets the blue axis. Okay, so that's actually intentionally creating a bad situation. But at least we can see what's happening. We actually can tell by just looking what's going on. And if you're in gimbal coordinate system, then when you rotate around one of these three axes, then that's what's going to get recorded in the animation. Whereas if you're in any other mode, such as world or local, and you just innocently rotate around one axis, what you'll find is that your animation is rotating around 2 or 3 axes. So the gimbal mode is the most helpful because it actually shows you what's really going on, and it hopefully will prevent you from getting into some dire situations. We'll look at gimbal mode later in the course when we talk about hierarchies and rigging. All right, so those are the key coordinate systems that you'll want to get familiar with. Primarily, you have view, world, local, and gimbal.